Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. Today we are going to talk about the topic shaft. Okay, the last topic of shaft, which is the limits and fits. Okay, so this content is taken from the book Shigley Mechanical Engineering Design, and all the images here is taken randomly from Google Images. So for shaft and all other components, there are two type of units. There are metric and inch unit. Okay, for the inch unit used in US, UK, and all the other countries that use them. But most the rest of the world uses the metric system. Malaysia use the metric system. Okay, however, uh, as stated in this textbook, no point. Okay, no point if we want to convert, we want to differentiate between terms and terms. Okay, we use what is used. If your company, if you're dealing with company that uses metric system, you use the metric system. You use company that dealing with company that use the inchi system, use the inchi system. Worst come to worst is to convert the result become what that suits you lah. Uh, and for this book, it is mostly discussed in Inchi system because the book is from USA. Okay, so no problem. The result that you get, just convert to in to the metric system. Okay, so this is standard apply to all. Given there are two, one is a hole and one is a shaft. Use the standard says that you always use the capital letter to represent the hole and the small letter to represent the shaft. Okay, this is the hole. Okay, you put the capital letter if you want to represent the hole, and this is a shaft. You put the small letter to represent the shaft. Okay. Okay, the standard for the shaft is given basic. The basic size is the size of to which limits of deviation are assigned. Is same for both members of the feet. Okay, deviation is algebraic difference between the size and the corresponding size. Basic size. Upper deviation is algebraic difference between the maximum limit and the corresponding basic size. Lower deviation is algebraic difference between minimum limit and corresponding basic size. Fundamental deviation is either the upper or lower deviation depending on which closer to the basic size. Tolerance is difference between maximum and minimum basic size limit of a part. International Tolerance Guide IT designate group of tolerance such that for the tolerance of a particular IT number must have the relative level of accuracy but vary depending on the basic size. Whole basis represents a system of fits corresponding to basic whole size, and the shaft basis represent a system that fits corresponding a basic shaft size. Okay, so this is all the terms and the standards used to define a shaft and a hole. Okay. Okay, you can see here is the magnitude of tolerance zone is depicted in table A11. Okay, this will say that the smaller the size, the smaller the tolerance. Okay, the smaller the size, the smaller the tolerance. Like say this my cap, this my pen cap, my marker cap is put in this, it become the tolerance is in within this range. Okay, within this range. Okay, however, this kind of hole, okay, this hole with my this cardboard represent a hole, and this is a pen going into the shaft, meaning that it's a larger tolerance. Okay, larger tolerance meaning that the value is either below 1. Okay, so this is the magnitude of tolerance zone. Also the same principle as before. The lower one value is the small tolerance. The bigger value is the bigger tolerance, and it is using the matrix unit. Well, at the last slide is using the inchi unit. Okay. Well, This magnitude of tolerance zone, table A13, also shows the selection of international grade tolerance in G series. Okay, for the tolerance grade, the basic is the simple, the lower one, the lower value, the tighter the tolerance, the higher value, the larger the tolerance. Okay. Okay, you should have the textbook with you, the magnitude of tolerance zone. Okay, because you should have the textbook with you because the word here in this slide is small. Okay, if you want to refer the better refer in your future, better have the textbook beside you. Okay, so you can refer it better. Okay. Okay, this slide is fundamentally the same that I said before. For the hole, you are using the capital letter, and for the shaft, you are using the small letter. Just remember that, okay? Because when you want to do the example and everything, it will, if the question says that question shows the capital letter, then you immediately know it is referring to a hole. And the question shows the small letter, it will refer to a shaft. Okay, just remember that. Okay. Okay, table 7 9 shows the preferred fit. Okay, table 7 9 shows how the letters are combined with the tolerant grades to establish a preferred fit. Okay, the ISO symbols for the hole for sliding feet with basic size of a 32 millimeter is H7. H represent the hole. Okay, engine unit are not part of standard. However, the designation H7 includes the same information as recommended to use here. In both cases, the capital letter H establishes the fundamental deviation and number 7 defines a tolerance of grade. So this is how you refer a hole, you refer a shaft to its designated symbol. Okay, when you read the symbol, you know what is the image of the shaft and hole. Okay, you have some overview what is the image, whether it is like this, whether it is like this. Okay, in tolerance term lah. Okay. Okay, this is the tolerance notation and equation. Okay, you should remember by now. Okay, for the capital D, represent a hole. Okay, for the small d, it represent the shaft. Okay, for the delta, U is deviation, is upper deviation, and delta L is lower deviation. Okay, okay. Just remember that. Okay, because in the question, it will just show you the symbol, and you should have known what is the symbol represent for. Okay, so that is all for this video. We will see you in the next video and also the last video for the chapter shaft, which is the stress and torque capacity in interference units. Okay, see you in the next video.